Let's see, couple of, I updated all the stuff online, except I forgot one thing I just saw, so I added a couple more wikis that are really close to what you can expect at an exam for you to practice with. I think I completed all the screencasts, so except for the one for today, all the stuff is online there as well. And the only thing that I forgot to do, I think, is add the do file from last time. So I'll make sure to put that online later today or tomorrow, and then all that should be complete. Yeah, then the only thing left to do is, besides studying all that stuff, is practice. You need some speed at the exam, and the only way to get it is to make sure that you have done all this stuff before. I added a slide here with all the stuff that I mentioned last time as well. This is the exam material, just to go through it one more time to be sure. So everything that was treated in class, everything that's on the slides, and the online material. Of course, there was much more online material there for you to check. So all the stuff that is there just for you to help you understand the stuff that I went through myself. If it wasn't covered on the slides or in class, then you can rest assured I won't ask you about it. So what cannot happen is that there is some internet resource on Canvas that I mentioned there and that I put there for your, basically to help you understand it better. If there is something else in that material there that I didn't ever talk about, I won't bother you about it. For many of the chapters, no, not for many, for several of the chapters there is a reading guide. Most of the chapters you simply have to know cover to cover. The exam code is OHV51, so a separate exam code if you're looking for the place and time where you need to be. It's on February 2nd in the morning at 9 a.m. And we are in Study Hub sections A through E, so that's the same place where we were for all the, for both the in-between tests. Then at the exam, well, you're allowed to use obviously Stata and the Stata help files. The Stata help files are PDFs. And if you have installed Stata, then in fact all these PDFs are on your laptop already somewhere, and you're allowed to use those. There are in these help files every once in a while links to URLs somewhere online. You're not allowed to follow those. So you're more than welcome to use all the PDFs that you have locally that belong to Stata and the Stata help, but nothing that brings you outside your computer basically. Also from the stuff that is on your computer, you're not allowed to consult the slides and also not allowed to use any preconceived do files. But let me first focus at what you are allowed to use. So Word, use Word to type your answers in. You'll get a document that is a Word file and you can type your answers in there, just as the example that I showed you last week. It's easy to have a copy and paste program, a screenshot program. If you can, that would be way easier for me. Use either the snipping tool, this is standard in Windows, at least in Windows 10, perhaps also in Windows 7 even, or use Paint. If not, my program will complain to me and then I have to figure out what that was that you have been using if you have another program to do this. This is convenient if you have output from Stata that you want to copy and paste in the Word document, and you could try your luck, perhaps simply copy and paste, so Control-C and Control-V might work as well, but this doesn't seem to work very nicely on all machines for reasons unknown to me. Then I don't think you really need a calculator, but if you want to use one, use the inbuilt calculator in Stata. So if you type DI for display, and then whatever it is that you want to calculate, then you'll get it back from Stata. Should be good enough. And as I said, I don't think you'll need it at all. If you need a dictionary, then you're allowed to have one there. It needs to be a tangible one and not one that is Google Translate or something else that is on your laptop. Okay, so that's all the stuff that you're allowed to use and nothing else. So, yeah, you know, the book, the slides, any pre-made notes, any other stuff that you have preconceived. Let's make a long list of all the commands that we need to know. All that stuff you're not allowed to use. You need to know these things by heart, or at least should be fast enough to find them back in the help. You're also not allowed to get in line or get in contact or otherwise communicate with others. No Skype, Messenger, Twitter, mail, and so on. It's a good idea to double check for yourself if you know how to turn these off. There are so many ways in which you can get messages sent to you. An update from this, an update from that. Make sure to have all that in the off position. And then, if there's something else that you have and you are in doubt about if this is allowed or not, simply assume that it isn't, and then ask. And then we'll see how that goes. Okay. Any questions about what you're allowed or not allowed to use at the exam? All right. Okay, we're running Windows or using a Mac with running Windows natively in bootcamp, and other stuff is not allowed. And the reason for this is you get a program that has an icon that looks like this, that monitors what you're doing. That thing only runs on Windows. This is because for those of you on a Mac it's not easy to access processes running on a machine. So on Windows it's relatively easy to keep track of all the processes that are running on your machine. On a Mac, the Mac will not allow this for separate processes, so it's more difficult to program this stuff. The thing to do is, well, first, and that might be the most complicated part, make sure that you download it from the Canvas website. I have now 2 links. The easiest link, if it works immediately, is the link to the actual file. The problem with that is the file has an extension .exe, and some computers will not allow you to download this, because a typical virus could also be something that ends at .exe. So try that first. If all that simply downloads to your machine, great, and then you're good to go. If not, I have the same file basically, but now I changed the extension to something else. You download that first, and then change the extension back to exe. It will, in all likelihood, work. But in the end, you'll have something on your machine, and I'll show you how that goes. Let's see. There you have it. So the icon looks like this. Normally I would simply show how this works on my own machine, but here this doesn't work so well because exactly what I want to show is now visible only on my laptop and not on the big screen. So I have a 1.5 minute visual of this. I think there is even some sound with that, but I can do the sound now. There you have the icon. You double click it. Apparently I talked way slower in the file there. Perhaps some talk about where to get it. It's convenient, by the way, to put it already on your desktop. The program is such that it's supposed to write the log file in the end on the desktop as well. Here you get it. You type your name, you type your student number, and then you get something like this, something in green on top of your screen. That is for the people there who are checking what you're doing. As soon as you have this green bar on top of the screen, we know that that program is running. So that's simply a convenience for us. Do not try to hide it. It's meant to stay on top, but in some cases it might disappear, then make sure to get it back. So this you have on all the time. When you're done, you double click. If you accidentally double click, you can click the left button and continue with whatever it is that you did. If not, you click stop, and then you get a file right there on your desktop that has an extension .enc. And in the end, when you deliver all your stuff back to me, you deliver 2 things: your Word document with all the answers in it, and this log file, and nothing else, by the way. So do not add all screenshots separately or a huge do file separately, and then figure it out in the do file yourself. The document has to be self-explanatory. Yeah.
How do you give it? USB stick?
No, you upload on Canvas. So I don't have an example there, but simply you go to at the beginning you go to Canvas, and I think I have that on the slide here as well. So let's see. No, so I don't want to go collect 194 USB sticks or something. So this would be the general idea at the exam. The first thing to do is boot up your laptop and close all programs that you're not allowed to use. Then start that exam monitor program. You'll see that green bar on top of your desktop. You go to the Canvas website, you log in, you download the exam material there. That, in all likelihood, that will be no more than 2 files. A Word document with all the assignments in there, and a data file that goes with it. That's it. You put those on your desktop, you close your browser again, so now you are not connected to the internet in principle anymore. You start with the exam, you don't open any connections with the outside world anymore, and when you're done, you deliver 2 things. A file with all your answers, that Word file that had also the assignments in it, and all the static commands and the output that is necessary for me to understand what you did, and some text that, well, explains what you did and why you did it, your conclusion, and on what your conclusion is based. So put yourselves in my position. I have to try to figure out if you understand what you're doing. If you just put a command in there, even though the right answer might be visible somewhere, then I do not know if you know this. So I have to be able to figure out if you understood what you did. Okay, as soon as you're done, you close exam monitor as well, and then you have 2 things that you can upload, that Word file and the log file, and that's it. That's how it goes. Any questions about the setup of the exam? Yeah.
So what would happen if you would, for instance, get a Skype message or something?
Yeah, then one thing has gone wrong already, that is you apparently didn't close Skype before you started. And I then see that. The trouble is, of course, I only see this afterwards. So what we don't want to have is actually that this is happening on the afterwards. So if something like this happens, you simply let me know immediately. I'll be at the exam there too. I'll make a note that it's you, and so that I know that as soon as my software complains that in your case Skype was opened or at least used a connection somehow, that I know that it was you and that we skip that as soon as we could. This is also why it is a good idea to try to practice a little bit under exam conditions, so that you know, okay, everything that I have is now closed. Because not for all these things it is so easy to stop them. It happened a couple times during an exam that somebody said, okay, I know that I have to close all messages, but I keep getting updates from, I don't know what it was. Do you know how to shut that off? And was it so clear? Yeah.
Can I not just turn off the internet and
Yeah.
make the exam and then turn it on again?
Fine with me. Fine with me.
Okay.
The only thing that, is there something that might not run? No.
Yeah, but then you
Yeah, sure.
already close your log file, so then it doesn't record it anymore.
Sure. Good enough for me. Any other questions about how to do this? Then, I can't say that often enough, so let's say it one more time. It's not about these numbers that you see, it's about the story that you write about it. So make sure to write a little bit more than what you think is necessary. Do realize that, let's say a standard way to show that you do not really understand the material is that you write an awful lot about the really simple questions. So if, let's say, question number 1 is how many cases are in the data, yeah, I don't need half a page about that. And then you write hardly anything about the more complicated ones. But as soon as it gets a little bit more complicated, add text. The whole idea is that you explain to me what's going on in the data, and for that you need words, and not only the numbers. A couple more tips. Make sure that you create a single do file that you make larger as you progress through the exam, and that you simply run from top to bottom all the time. Instead of, where I see many people do, either typing interactively or copy pasting pieces of code and then running that. As soon as you've done this for, let's say, 20 minutes or so, and it's all, becoming one big mess, this is running the risk of being there for 2.5 hours, then figuring out something went wrong way in the beginning, and now there's nothing more you can do about it. It's good practice, especially when you are under time pressure as you are here, that you have one do file that runs start to finish, way easiest. Yeah, then a good idea is, I do not know exactly what the exam is going to be just yet, but it might very well be that at least part of it is coming from the data file that we have from our own class. So it's a good idea, I think, to browse around a little bit in that data file, think about what reasonable questions could be, and who knows, there might be a question at the exam that is exactly about these data. Then it might be that I put somewhere, okay, don't bother checking the data for this assignment, but if I don't, so if I mention nothing, then you're responsible for checking the data yourself. So even if I ask for, I don't know, compare these two groups on this interval scaled variable, okay, you should be thinking t-test, then still, check your data for weird stuff, unless mentioned otherwise. Then practice a bit under exam circumstances. Good for many things. For instance, if your laptop is up to it, if your Stata is up to date, if you can put up with the speed yourself. I mean, you have to complete all this in 3 hours or so. So, you know, it's a good idea to try and do that. Then, the forums and the wikis are there to be used. I will be there as well, and I've tried thus far to be, let's say, as fast as possible for a lot of the questions that came up. If you get closer to the exam, it's more difficult, first of all, to follow what's going on, because many more people will be there, and also for me to follow up on questions. So on the evening before the exam, you know, at 12:30 in the night, I'm not checking anymore what you're doing, and then, you know, questions are just useless at that point. Yeah, then, in all likelihood, there will be something at the exam of the kind, okay, here's data, and do something. So sort of an open question where you have to go through the data, and yeah, there are many ways in which you can do something with the data. That is a very good assignment for me to judge if you know what you're doing. And the disadvantage is it takes quite a bit of time, because let's say after 2 lines of code, the group can already be split in 8 different versions of what people are trying to do. And that causes that grading all this stuff takes a while, and in all likelihood will take the full, I think, what is it, 3 weeks or so that I have for this. If for some reason you are a special case, you are waiting to, I don't know, go to some next stage and it cannot wait, let me know right after the exam, because especially just looking at, okay, this is enough or not enough, that's easier to do fast. Otherwise, yeah, bear with me, I'm grading as fast as I can. Okay, then just an announcement that worse has yet to come. Here, finally in the right order, the stuff that we did. First, Stata, then it's all about relating sets of variables to each other, an x to a y, and we did a little bit about the general logic behind hypothesis testing. Then in principle, the standard order would be, okay, before we collect some data, we think about what the sample size should be, but all that sample size stuff is dependent on the kind of analysis that you're going to do afterwards. And at that point in time, we didn't really know what kind of analysis that would be, so I postponed this a little bit. Normally, you would want to do this before. Then you have your data and you want to do some measurement stuff. You have item batteries for some of these questions. For that, we need scale scores, so we did that. And then in the end, actually, we end up with different kinds of analyses, and this is a set of 5 different things that we went through. And in fact, all the stuff that is related to an analysis of different kinds of data is about this and an extension in some way. So this is the third method source. Okay, if y is not interval scale, but it is binary. We want to predict something that's 0, 1, yeah, then we need to do something else. And that something else really is a lot like multiple regression, but slightly different. And you need to know what the difference is. So we had clustered data, which is not a good thing, was against the assumptions in multiple regression. So we need to know something else that we can use to deal with this. It's called multi-level regression. We'll do it in the next course. And then we only checked, is there a single dimension here in an item battery with that complex alpha? Well, what if there are more dimensions in the set of items in the item battery. Well, we can do that too. It's called factor analysis. And then all the stuff that we now sort of swept under the rug, the more complicated stuff about p-values and confidence intervals, what exactly is that? There's more of that in the third methods course as well. Okay, so in principle, I'm done in the sense that all the material for this course we now covered. So I will stay here as long as questions last, basically. And I cannot imagine that everybody's already done with all the preparations and feels that there are no questions left. So let's hear it. Anything? Yeah.
Could you please go back to the slides what further you take to the analysis, what the kinds of analysis that are?
Oh. This one? All dependent on what the variables are that you want to compare. Two categorical ones. For that we did a chi-squared and a Fisher's exact. Categorical one with two categories and an interval scale variable. For that we wanted to run t-test whenever possible. Two interval scale variables, and it's called correlation for simple regression. Multiple regression if we have more than one predictor for an interval scale variable. And then analysis of variance in different kinds of flavors, which is actually, the same as multiple regression. That's what we went through. One thing that I've seen before, I mentioned it I think once or twice here to the people who were here to practice their material, what you can do for yourself if it helps you is try to come up with, let's say, sort of a decision tree about what to do for a t-test that's, for instance, relatively easy. Binary variable on the one hand, interval scale variable on the other. What do? We test normality. Normality okay, we run our t-test with unequal variances assumed. Not okay, we try to make it normal. Does that work? Okay, now we can do the t-test. Doesn't work, okay, we do rank sum. If you have that lined up in your head, or you first write it down and then you line it up in your head, that's usually the easier way to do it. Then, well, it's kind of too hard actually. It's the same process all the time. Other questions? Too early for questions? February 2nd, how far away is that? 14 days. Yeah.
Can you go to the last exam exercise for the exam?
Yeah, sure. I'm more than willing to do this, but if I do this, will take some time. So I want to stick to, let's say, questions that can be answered fast for now, and then as a last resort, we go through that. Any easy questions? Easy means no likelihood the answer is so.
When should we use p-value or just score?
Oh, okay. So the question is partwise or piecewise correlation versus correlation. And remember what the difference was? Anyhow, has to do with the way in which the command treats missing cases. So this one, correlate, if you put a long list of variables here, 10 or so, it will create a correlation matrix of these 10 variables, but it will calculate the correlations on those cases in the data that have cases on all variables. So that, in principle, if you have lots of missings, it might be that this is a very small part of your original data set. But in fact, it would be the same set of cases that would be used if this here, all the variables we have written over there, would be the part of a multiple regression. So if you have, let's say, a y and x1 and x2 all the way up to x10, then running a regression will only work on the cases where we have data for all the variables. So if you then type the correlation command, the correlations will be calculated for all the cases that will be used in a subsequent regression. So in that sense, it might be convenient. If you just want to know for each pair of two that we can create, for each pair of two, I want the correlation between these two, then try this one. Well, okay. What else?
testing that we have to check sortability.
Yeah.
Can you do as well for multiple regression?
Yeah, so the question is, nice, that decision tree for the t-test, give me one for multiple regression, and in principle, possible, but the disadvantage there is that tree will be longer, and also, let's say, less obvious. We had somewhere a slide where, let's say, that the whole process of what to do from start to finish was in there. Browse back in the slides and you'll find it. A standard regression run, I think it's called. So it starts from checking your data first and making sure there's nothing weird in there and replacing all the stuff that has to be replaced and getting rid of things that are not right. And then a standard regression normally would start with, okay, let's have a look at the data that I have and start with, let's say, a basic regression model. So I know what my interval y is, the thing that I want to predict. And I look at my data, if I have a long data set with just, let's say, too many predictors to handle, which of these do I want to use? And the first thing to try is look at what makes sense here and try that. And for instance, you start with one interval y and let's say 6 or 7 of the most obvious predictors. Just you put them in as they are, except for the categorical ones. There you have to create separate dummies, otherwise you're doing something that's simply wrong. That's the first thing to do. You have a look there and you see what happens. You try to interpret for that first regression table, do these effects that I find make sense? For that, you need to know what the variables represent. If you find, let's say, income with increasing income, happiness decreases dramatically, which sounds unlikely to me, then you have to double check if something has gone wrong. So one first check of how good you are doing is, just see if you can make sense of the effects that you find. Are these in the right direction? Does this work at all? Okay, as soon as you have that, there are a couple things you can do to make the model better, and here it starts to become fuzzy because there is no standard order in which to do this. So, you look at your interval scaled variable. Is that something that is restricted in some sense? Should we make sure that we only predict values that are above 0? Well, if yes, you have to do something about it. For the interval scaled variables that we have now, as they are, we just put them in. We have linear effects. Is there something better than linear that we can come up with? And you have to try a few and see if it helps. If it doesn't help, well, too bad. But, you simply continue until you're done with, let's say, the stuff that you can. Interaction effect. Think about which of these combinations of two variables might be a sensible interaction effect in this model. At some point, you start to feel, okay, I've tried all that I can do here. From the gazillion other variables that I have, none of them make much sense to add like this. So now I think I'm more or less done. Let's start checking a couple of assumptions here. Check for outliers, check for normality of the residuals, check for all the standard stuff. In all likelihood, well, if you're lucky, you find that that omitted variable test turns out well, suggesting that, well, whatever you did with the variables as is was good enough, apparently. And all your assumptions seem to be nice as well. Great, this looks like a fair representation of the data. Look again, what do we see? Which effects do we find? So what's going on in the data? You conclude about what's going on in the data and say, well, this looks great, nothing wrong with that, and we're good to go. Okay, this is when it all goes well. In all likelihood, what will happen, you'll find a couple of outliers, so you have to deal with that, and you'll find a couple of assumptions that do not work out, so you have to deal with that as well, and then keep reiterating until you arrive either at a model where you find, okay, now my assumptions are fulfilled, looks like we're good here. I look at my model and I, so it makes sense what I find, and this is it. Or you have to conclude, okay, I've tried all that I can do, and still I see that there is something wrong here with my data because assumption 3 and 5 are typically not fulfilled. And then the only thing that you can do is write that. I tried everything that I could. This is as good as it gets, and I can't get anywhere with this. I see that there is something actually wrong here. That's just how it is. And up front, there's no way to tell. So it could very well be that this is a correct answer at the exam, simply because the data won't allow you to do anything that's better than that. That's as close as I can get to, let's say, a general description if you what you can do.
Can
Yeah.
you
so in general, for the one-sided tests, at least for here, we should be decided that not bother with the one-sided test too much. But in general, they might be sensible to have the argument to do it, but you put yourself, in sort of a vulnerable position because it looks like you're sort of fishing for the truth of it. So the easy answer would be, okay, for now, just disregard all the one-sided stuff. But normally, in practice, if you find this, if there are two ways to do it, both, let's say, reasonable in some sense, and one shows something above 0.05 and something else shows a number below, it's never a position where you want to be in, and then the only thing to do would be to really hard if it actually is the argument for a one-sided test. We are moving forward. What else? Okay, so what I'll do next is, there was one, yeah.
What would be a good way of phrasing when you do the ladder command and you choose for these precise formula? What should you argue for that?
Well, first you should argue why you start with the ladder command at all. And the ladder command you need only when you have a variable that does not have a normal distribution, and you want to create a variable that has a normal distribution. So that's the first thing you mention. This has to be normal. For instance, because I'm testing for a t-test, and it is. So let's see what we have. Then you get 8 or so of these different transformations, and we're looking for one in which normality is not rejected for both of the groups, if it's about a t-test, that we have. So then you simply go through the list and you see, okay, there are 2 of them, the square root and 1 over x, that both fulfill these 2 rules. And then in principle you can choose whatever you like. So I see here that I can choose either one, this one or that one. I choose square root. That's it. Nothing else necessary. It would be nice if afterwards you double check by running the swilk command, because the output from the letter command is based on SK test, that's only one of 2 tests, that's normality. So double checking using the other command might be a good idea as well. If you're then still good to go, so that's it. I now found a transformation of my original variable that is normally distributed in both groups. So if you do the t-test.
The point is that the probability, it says it's the probability of a chi-square. That was worked out. Because when you do the table, the probability of the title means probability of chi-square above 0.05.
The output of the letter command, it's a long list, actually the long list is the direct result of a normality test, a very crude one, based on a chi-square. But the only thing that you need to consider there is normality violated, yes or no? No.
So just pick the best number.
If you have any choice, choose the one where that number is highest, I would say. Okay, so then last question. Last question from the practice exam, where the thing to do was a bit more open than for the other ones. And the question itself was, in 7 we already looked at a variable that was called soccer score. You could score a 0 there if you had all the questions wrong, or a 10 if you had all of them correct. And another one that was called soccer guess, and that was a question before you got the quiz, how many questions do you think you'll have correct? And in question number 7 there already was some stuff about predicting soccer score from that soccer guess. That actually worked. Let's see if we had anything else there besides that one. Alright, whether you played soccer yourself. Okay, anyhow, the final question was, well, you now have a really large data set to come up with predictors for that soccer score that you have over there. Okay, just do it. That was the idea. So the first thing to do would be, well, it would already be a good idea to write I have a really large data set over here, but clearly the data set was not collected with, in the back of our minds to predict soccer score. Otherwise there would have been way other variables in there, I guess. So we'll have to look if we can come up with anything that makes, yeah, let's say, a vague sense to be predictive of soccer score. Well, we can have a look at what we have in the data. My guess would be all the standard stuff would be a good idea to try, so something like female and age, that is not so bad to at least compare. So that would be the first thing to do. You make a run through the data, trying to figure out which of these might be reasonable to at least give a shot. Age, female, own a business. Okay, I can try net income. That was the question where I asked what you think that you earn at age 35 or so. I can imagine that the income itself has not much to do with it, but perhaps it's sort of a measure of how optimistic you are, and who knows, perhaps that related to what you score here. Whether you feel you're doing better than average. My assumption would be, well, in all likelihood, if you think you are better than average, perhaps you indeed are. And if you're better than average in your courses here, perhaps you're also better at quizzes about soccer, who knows. So that's the closest I can get to something reasonable here. Well, then that happy penguin variable, that shouldn't do anything because that was randomly distributed. Then we get a long list of item batteries, so feeling 1 through 17 or so. If you think that it is a good idea to add these, that feeling battery was about how happy you feel, then do not add them separately, but add them in a way that is better, namely after running an alpha command, all these feeling variables. So I'd first like to see if there's something there. Here we have 0.82, and there's let's say, a little bit of room to improve here, but just to get an initial idea about whether or not this adds something at all, I can simply create the variable here. Now I created the variable at the same time. Let's double check. We have a negative sign over there. That was for feeling 1. Feeling 1 was I don't feel particularly pleased with the way I am, I think. So that is one that is negatively formulated, and that one has a negative sign. So this would mean that the higher scores on the happy variable that I created indeed coincide with the people who say they are happier. So now I could add this as well. Let's get rid of this one. Let's give it a whirl. Okay, so here we see already that this happy variable that I just created doesn't add anything here to the explanation of that soccer score. So at that point, I wouldn't bother anymore with trying to make sure that I can get my alpha value a bit up from 0.82 to 0.825 or something, because it doesn't help anything at all. So I wouldn't bother with that so much anymore. Same thing for quite a few of these other ones. Let's see, that hit target variable. I could simply try it and add it. Oh, where am I? Let's see if we have anything better here. These are the separate quiz variables. No stats, that already was a variable that was created based on the separate item. So let's try that too. Okay, so this is, let's say, our first run through the variables that we have. I didn't do anything in particular here because let's see, no, I do not have any categorical variables. Otherwise, if I would have had them, I would have put an I dot in front of them to make sure that we get separate dummies. Okay, so just to make sure that we actually have an example of that, let's add one. Not sure if that really was a variable. Yeah, I think it was. So here you have it. Again, this doesn't help us much, so I'll leave it out in a minute, but just so you know that if you add a categorical variable here, you need to put that I dot in front. Okay, so let's immediately get rid of this one and look again at the one that we had just before. Okay, so if you look at what works here and what doesn't, the obvious one is that soccer gets, which is not so weird. So the ones who think up front, yeah, I know something about soccer, indeed score better than the ones who think that they have no clue. Females, there's a difference there as well. So we have that females score worse here on the test, about 1.3 points on average. Age doesn't seem to matter, at least not linearly. I wouldn't really expect something from age here for two reasons. First, I wouldn't see why that would be an argument at all, why age would help. And the second is we do not have a lot of variance in terms of age. You're, let's say, roughly speaking, all equally old. And if we have hardly any variance to work with, then it's not very likely that we'll find something. Then better than average, that one, oh sorry, I'm missing one here. Net income, so that doesn't help us at all. Better than average, that does, if you, which is sort of weird, if you score better than average, or at least if you say that you score better than average, probably coincides, then you score lower on that soccer score variable. Okay, what could be consistent with that? So I'm trying to see if this is all making sense.
People tend to overestimate themselves.
Okay, I would agree, but how would that lead to an effect of this kind?
Well, if the majority says they're above average, they're actually on the average, but they think they're above.
Yeah, but here the ones who, what you need to argue is how it can be that the ones who are claiming they are better than average actually score less on the test.
Maybe that has to do something with the people who know lots about playing soccer, So people who know lots about soccer tend to overestimate themselves.
Yeah, I don't think that you even need the overestimating here. One idea would be, okay, if everybody would be exactly correct in the sense that if they say, I think I'm better than average, then they are. So nobody is overestimating anything. Then it could very well be that the ones who say they are better than average and who are better than average, those are the nerds who don't play soccer. Okay, so they know nothing about soccer at all. And this is consistent at least with that explanation. Okay, so, or the other way around, the ones who know about soccer, you know, they're sitting in front of a television all the time when they should be studying, and this is why they are worse than average. Could be. In any case, there is a negative effect here, and the other ones do not do so much. So here, what I would do at this point is say, okay, this is the set of variables that I started with. I'm going to get rid of the ones who are really the worst. So let's see if I can get rid of first net income. That doesn't really do anything at all. Really far away. Let's see what happens then. Okay, the rest doesn't change so much. For age, well, I might be willing to give it a try to see if something nonlinear might work for age. So basically I'm ready to discard age as well. I'm just giving it one more try here. Oh, I forgot how that worked again. Is it like this? I always mix up these. Yeah, there you have it. You had a question before that?
Yeah, so the initial model, if you're going to write on the Word file, do you first include net income and then put on a regression and say, okay, it doesn't add up, here's a new one, or do you have to say that, or is it unnecessary information?
Well, the easiest, you know, what I'm trying to figure out is if you can, if you're doing something that makes sense and if you can read the table. right? So if you are telling me, okay, I'm going through the data and I think that these variables at least are worth a shot in the beginning, okay, fine. Then you run your initial regression and you go through the results of that initial regression. If you go through the results in a way that is correct, then I know that you can read a regression table. If you then say, okay, I did the following, I checked net income, and I saw that this one has a really high p-value, and I simply disregarded it, also because I do not have a real argument why it would work at all, but okay, so that one's gone. Now I also really do not think that age will work. What I try to, before I get rid of it, is to give it a whirl with a transformation of age, perhaps that might work. And that I do through that FP command. Then again, you have to interpret something new, because I do not know yet that you know how to read that. Again, if you show that once and it's correct, then, if you do this for 5 other variables, there is no need to, in the output, and now I believe that it works. So let's see if it does work at all. Okay, and the easy way to see that it doesn't work is there. Here we have that FP output where different kinds of transformations are tried. The row here, the one with m equal to 2, is the row where, let's say, the most complicated transformations have been tried. So here, age is being replaced by 2 transformations of age, let's say age squared and square root of age. And in fact, the only thing you have to look at this point is, well, this is by definition the best model because it has the most elements in it. And this is a comparison of the model where we have only one transformation with the one that is best. And here, apparently, it doesn't get any better. Same thing here. This is a test of the linear model, so the one with age in it. And we compare it with this one. This one is apparently not better. So it doesn't make much sense here to include either this or that transformation of age. Neither of these are any better than the one that we had. So here I would argue, okay, so now I really do not see any argument why we should include age at all. Let's get rid of age as well. Okay, so back to this one. So what I'm trying to do here is bring back the set of predictor variables that I use to something, let's say, a bit more manageable, 6 or 7 perhaps, and we're more or less there. There we have it. Okay, still, not all of these are statistically significant, and you might want to conclude something about, okay, that hit target variable, well, perhaps there, yeah, you could argue, what was that again? That is, if you do something like you put your finger in the air and then you pinpoint with your eyes closed to something on the screen, and if you would do that actually, then you're not very likely to hit that at all. So if you say something there, let's say 4 or 5 or so, that's perhaps indicative of that you have been doing some weird stuff here, and quite a few you have. So these are in a way a bit suspect. So one way to try and see if I can still make something out of that hit target variable would be, okay, the ones who say 4 or 5 times, these are definitely lying. And I do not know if that has an influence on the actual result, but at least this is a variable that has a meaning there. I think you're lying, basically. So we could try to create one. Margin 3. Okay, now I take the original one that I had, place it there, and instead of hit target, use that one. Okay, again, it doesn't help. So I tried the original one, didn't work. I tried to come up with a different kind of explanation here, also didn't work. So at this point, well, I would say that one could go as well. Okay. Okay, what else do we have up our sleeve? What could we do here? What's next? We did a couple things more, not so many. Yeah.
The items are related to each other.
Yeah, so that would be one way to go. So there are more things that you could try to transform. For instance, that no stats, perhaps there is a better way to include it than just as a main effect. Something else that you could do is have a look at the cases that you have in the data to try to figure out if there are, for instance, outliers in there or other weird things that do not make sense at all. Okay, so what do I type if I want to go that direction that you suggest? What would be the next command that I need to do here? I could try. Any clue? So one would, well, you know, let's stick to, for instance, the DF betas. I get 1, 2, 3, 4, 5 different DF betas back, corresponding to the 5 variables that I have over here. And let's see how we can deal with that. Just peeking for a minute what these variables are called. Yeah, they're called underscore DF beta, that's indeed correct. Here it helps if you know how to write a for loop. See, it's working. Okay. So now I have standardized DF betas, and for those that like to see if there are any values in the DF beta there that are either smaller than -3 or larger than +3, and perhaps I could shortcut that a little bit. Okay, so I want to know when, in absolute value, that standardized DF beta is larger than 3. So I now create another set of 5 variables here, defined as the absolute value of that standardized thing. Nope. Let's see if that works. It does. Okay, so now I have the ones that I really need to have here. Identifier in my data. ID. Let's peek if that works. Okay. Like this. Double check. Again, you can write the for loop if you want, or do it like this. All of that will work. Okay, you can start to feel why it is a good idea to be fast with these kind of things. Now, you know, I'm sort of typing where I'm not looking, which makes it a bit weird. Oh, and I don't want 2 here, I want 3. Okay, there we go. So these are my outliers, and I have a couple. 2, 40, 59, 81, that is for that first DF beta value. 2, 40, 81, and 90, 2, 40. Okay, so the 2 and 40, I see those all the time. So it looks like these are weird in the sense that what we get there is totally different from what we normally have. Could try a summarize command as well to see how big they really are. Okay, so this is quite large values for that DF beta, and case number 2 and number 40 are prime candidates to have a look at. So the first thing I would now typically do is double check if I rerun my regression without these two cases, does that make a substantial difference in the sense that variables that are not significant now do become significant, or the other way around. So that will be my first try here. What did I say? 2 and 40. Okay. Okay, so we have significant values over there. Happy and no stats are now no longer significant, or are not significant. I'm not sure if they were at all here. I don't think so, actually. Okay. 3, 1, 2. 3, 1, 2. Okay, so I look at my outliers here. I saw 2 that I found in 5 of these DF betas. I got rid of these 2, and that doesn't change much. So I double checked here for outliers. There are 2, but they don't mess up my data a lot. Okay, so that's one thing to try. The other thing would be to look for interaction effects. So one thing to consider would be, okay, for which of these variables, which set of 2 variables out of the 5 that we have here might be reasonable to consider an interaction effect for. And the only way to look at that is simply think hard about for which 2 of this might make sense. Oh, and by the way, one thing before that might be a good idea, and that is looking at the variance inflation factors. Do we have any variables that are sort of in each other's way here? All these are supposed to be, well, 1, ideally, and they are really close to 1, so this is for sure not an issue. Multicollinearity is not an issue here. Yeah?
I was wondering about interaction effects. So I understand about interaction effects that you have, if you have 2 categories and you add an interaction effect, you see, you see whether they have a different slope to the line.
Yeah, indeed.
Yeah, but how did that work so interval times interval values?
Yeah, that makes it more difficult to visualize, but the principle is actually the same. So what you would get is, do I want to write that here, or can I have an example of this one?
So it makes a difference, for instance, if you have little money or if you have a large amount of money, if you, for instance, buy lots of shoes or little amount of shoes. So is that...
Yeah, but yeah, I don't think it's a good idea to go with another example, given that we're now looking at this one. So let's first try one, for instance, with the first 2. So that's the easy one, soccer guess times female. So the argument would be perhaps the effect of soccer guess on soccer score is different for boys than it is for girls.
Yeah.
Okay, so you know, if a girl says, I think I know 4, and this is a decent estimate. If a guy says, I think I know 4, then, you know, that doesn't help. You can see if that is actually the case. And the standard way to do it, or the easiest, would be simply to like this, and then add this one as a predictor to the model. Now at least you have the variable. You can do it also with the hash tags if you prefer. Oh. This female. That'll be enough. Well, almost. So what did we have here? Okay, soccer guess that has an effect. If you think you know more, you actually do know more. Female had an effect. There is now not a clear effect of female anymore because female is in there twice, once here and once there. But you do see that, yeah, it's a pity that this one is not really statistically significant. So if for a minute we assume that it is, so add a mental 0 before the 6 here, then what you would see here, well, is we have an effect of that soccer guess of 0.6. And if you are female, then the effect of the soccer guess is not 0.6, but 0.6 minus 0.3. So this is actually consistent with what I suggested. So, or is it? Let's see. No, it's the other way around, actually. So for males, we have an effective soccer guess that is 0.6. For females, we have an effective soccer guess that is 0.3. So it's more useful, in a way, to know the soccer guess from a guy than it is from a girl. And that is...
If you would do that then with... what's better than, for instance, with happy.
Okay.
It's not significant, so that's an interval variable. Could you maybe...
Yeah, so let's show the interact command as well. That's a bit easier for interval scaled variables. Soccer guess happy generates yes. Oh. Okay, now to not mess up the output more, let's just stick to that one. There we have soccer. Okay. So I maintain the original variables there, so soccer guess and happy are in there as well. It doesn't look like there is a significant effect here, but if there would have been, this is suggesting, well, there is an effect here of soccer guess on soccer score, it's 0.6. And the happier you are, the larger the effect is.
Yeah.
That would be, that's not true in this case because there is no significant effect, but if there would have been, then that would be the conclusion. And what makes it convenient in this case, because we have interval variables here to use that interact command, is that the interact command makes sure that the product here is taken as a difference from the mean value. And that causes that, what I could say here as well, on average, that is for average values of happiness, the soccer guess effect is 0.6. Okay, have a look at the slides when we went through this command. But the most important thing to get here is, well, this allows you to do actually two things. First, to look at the effect of soccer guess as dependent on the happiness score, and the other way around as well. You can look at the effect of happiness as dependent on the soccer guess score. So there you could likewise argue the effect of happiness, well, all non-significant here, but is 0.3, and it is larger the higher your soccer guess is. Yeah.
So there's no easier way to find interaction effects than just try the ones you think are more possible.
Yeah, well, okay, so the first thing to do would be simply to think about what might make sense here, and I'm the first to admit that here, most of these don't make obvious sense, which is a direct consequence of the fact that the data was not made to predict this. So what you can try here as well is a run through all the potential interaction effects. I'm not sure if I want to go there at all. Trying to remember if I showed you this as an example or not. Probably not. Okay, let's not bother with it. There is a sort of an automatic, or at least more automatic way to cycle through all the potential interaction effects that there are, but the output is a little bit messy and, so the easier thing to do would be simply to think about which of these makes sense. Do not force yourself to try all sets of 2 from the 6 variables or so that we have. That will simply take too long, and you might stumble into something purely by luck. But the thing to do normally would be think about which of these variables would be likely to come up with an argument for. So for that female versus male argument there, I can imagine, in general, I think guys are more optimistic and shout something at random than girls. So I can imagine that you have an argument there, and even that is quite far-fetched. So it starts from there, thinking about what might work. Okay, so at this point, let's say that where we have the one with female was actually quite close. So let's leave that in. Even though this one was officially, let's say, not statistically significant, it might very well be that I'm going to do a little bit more with the data, so that 0.06 that we had there now actually falls below 0.05. So I certainly do not want to get rid of too many variables that are really close to being statistically significant. So let's double check here. What did we have again? Yeah, so here we have that interaction that was indeed close. Okay, and oh no, I did, yeah, exactly the wrong one. Yeah, pay attention. Same thing with the double hashtag. I'm asking for both of the main effects of the variables that we have here. So the main effect for soccer guess and the main effects for female. I accidentally forgot here to type the C dot for covariate for soccer guess in there. So it was assuming that soccer guess is in fact a categorical variable, and it made separate dummies. I repaired that. So this is 2 ways to actually estimate the same thing. So whatever works best for you. You could use either one. Okay, so at this point, I'm more or less through what I can do with the data. The only thing that I didn't do at this point is for the variables that I have here, double check that there are no coding errors. And I think in this actual exam there was a remark at the beginning saying that, okay, don't bother checking the data. Yep.
There was also something that you could add the y square, or the y to the power of 3, something as a variable in the end.
No.
Something that you said about 2 weeks earlier.
Yeah, I know what you mean, but it didn't suggest that. That is actually what the test does. At this point, I didn't transform so much here. So I'm starting to get a feeling, okay, either the model is not working very well, and I wouldn't be so surprised given that, we're not very clear about which variables would actually work here. Or I'm missing the right transformations here, perhaps. So one thing to do here would be to try this, that omitted variable test. And behind the scenes, that stuff with the predicted variables and then raised to the power of 2, 3, and 4, that is now happening behind the scenes. But what this command is doing is it's helping me trying to figure out if there is something that can be gained by transforming the predictor variables that I have in a way more than I did already. And this one is looking actually quite decent, way above 0.05, suggesting that there might not be a transformation that I could try here that would help. And just to make sure that this is indeed working well, this is the second way of trying that command, where the RHS, stands for right-hand side. And now you see here, this one is statistically significant, exactly what I didn't want to see. So this is suggesting here, so this one was fine. This did what you were hinting at. So you create the predicted values for y, and then you create the predicted values squared, raised to the power of 3 and 4. That as a group you add as a predictor, and you see if that makes a difference. And if it does make a difference, then there is a reason to keep trying transformations. Okay, we were in the clear here, there was no problem. The other thing that the immediate variable test does is, well, it can take squares of all the variables that you have, add all these as predictors, and see if that helps. So you're assuming, okay, let's look at all the variables, and let's assume that all of these are not linear, but in fact curvilinear, and see if that makes a difference. And apparently here, it does. So this is suggesting I'd better try to transform the variables that I have here, for instance, that better than average variable, or that happy or no stats variable, in such a way that it fits better, because there is some room for improvement here. So the next bit would be, I don't want to do all this because it starts becoming tedious pretty fast, but that fp command that I did with one of the other ones, which one was it? Did I get rid of that already? Where is it? Oh, there, yeah. With H, I'd like to do that again, but now for the other ones. Okay, so I'll try this one. Normally the most appropriate candidates to try this are the ones that are statistically significant already. And it's just that you can try to find a way that is better than what you already had. So let's see. This is why I start with this one. Oh, yuck. Okay, let's see. Yeah, same thing, unfortunately. So here we have the best model that Stata could come up with. It had better than average raised to the power of -2 in it, and better than average raised to the power of 3. That's the best one, and this one is not worse than that one. And this one, and that is the one that I started with, so with better than average as a linear effect, is also not worse. So apparently it's not better than average that's going to help us out here, which is a bit of a nuisance. Okay, so what I do here is, I'm not sure if it's a good idea to go through all these at this point, but I try the other ones. At some point, either I find one, and in all likelihood, no, there is no likelihood here. It might happen, might not be, because the test that gave us so much trouble there is based on including all the squares. So the only thing that I know is if I add the group of squares for all the predictor variables that I have, that together is going to make a difference. Unfortunately, I have no clue anymore what that is representing, but to get a better prediction, that would work. So I try all the other variables here, see if it makes a difference. If it doesn't, yeah, then there is simply nothing that I can do anymore. And I start with the testing of my assumptions. So I go through the list of all the assumptions that I have, normality and heteroscedasticity and what have you. And then I see what comes out. And at this point, when I've basically tried all the interactions and transformations that I could try here, if I would find that, let's say, 4 of the 5 assumptions, in fact, are okay here, I would simply stop and say, okay, I see here that OV test has given me some trouble here. And perhaps there is something else that I can do, but I really do not know what, because all the stuff that I can do here is more or less done. So I know that this is not okay. But then again, all my assumptions are fine. So this is the end of the analysis, and the final model that I'm going to present is, okay, not this one, but the one over there. And you come up with a final conclusion of what's going on here. So you see that there is the strongest effect of that soccer guess, that there is an effect of this variable being better than average, that there is almost an effect of this interaction between soccer guess and female, and that is pretty much it. So if you would have done that, so the only thing that I skipped for time now is going through all the separate assumptions. Some of these, in fact, you can still repair using robust statistics. So let me show just one, normality, for instance, predicts residual. I call the residual E and I do a normality test on that. Oh, where did the mouse go? There. Apparently here, normality not violated, so that's pretty decent. Heteroscedasticity, or actually I'm testing for homoscedasticity here. Head test and head test right hand side. Let's see. Also, fine. Can look at the plots as well. See if that helps me. Not too bad. Looks like noise to me, but perhaps here. Can imagine that these are in fact that number 2 and number 40 or so that I left out at some point. And if I now get rid of this plot and instead ask for these. This takes a bit longer. There you have them. Again, so what I hope to see here is, let's say, obvious transformations of my predictor variables that might work better. Okay, here this is really difficult to interpret because this is my interaction effect already. Here for the happiness variable, again, 2 of these outliers over here, but, you know, something curvilinear, I wouldn't really see how that would fit better here. And I think the same for these other ones too. Here, an outlier. So again, this is not helping me much, I think. Let's see, did I miss any of the assumptions here? I did the various inflation, not sure on which model that was, so I can double check it here to check for multicollinearity if that's there. Oh, yuck, these plots again. Okay. What was that? Yeah, okay, so this is actually quite interesting because if you would have had your initial model here and looked at these, then there might be a reason to worry about that this variable over there as a various inflation factor, well, not above 8 or 9 or 10, what is the default in the book, to start to worry. But it is a bit on the high side. Here I do not mind so much. Why would that be? Sorry? Where did it come from? Yeah. Okay, that's let's say the start of a good answer. Interaction. Could you add a little bit to that? Yeah. So female is in there twice, so that we have variables now in our set of predictors that correlate. That's not so weird. We just made them ourselves. So here I do not mind so much about the fact that these two correlate, because I created them myself, and I wanted to see if there still would be an effect if I would add these. So about these I don't mind so much. Okay, so this is also quite decent. Linearity looked okay in the plots. That's pretty much showing indeed what I suggested. So even though that OV test didn't work out well, all the assumptions are now okay. The only thing that in principle could go wrong here is that still the thing that we're predicting is between 0 and 10. So we could double check here if the actual predictions, at least in our data, are indeed between 0 and 10 and are not beyond the boundaries of 0 and 10. That would still be a reason to try and do something about it. Okay, I don't want to see these plots again because it takes too long. This is a tab of our predicted values, and there are starting from 1.6 all the way up to 9. So they're even within the 0-10 interval, and we could have had values above 10 or below 0, but we're lucky here apparently. So this would be an argument, okay, let's not bother with trying to transform our y variable in some way so that we can make sure that they are between 0 and 10, because they are, at least in the data. So at this point I would stop and say, okay, I did all that I can do. In the end, the model is fine in the sense that all assumptions are okay here. The only thing that is not is that I see that OV test command is giving me output that I do not like. So in principle, there must be something that I can gain through transformations of my predictor variable, but I cannot see what it is here. And this is basically it. So we conclude with this model over there. End of story. Perfect score. It's not that complicated, actually. Yeah. No, both should pass. So if either one is giving you trouble, has a value below 0.05, then you need to do something. And in both cases, what you need to do is come up with a differently fitting model. And usually that means transforming your predictor variables. And in principle, it could also mean transforming your target variable instead. Any questions left about this? That was a deep sigh. Yeah?
If you transform one of your variables that you later also apply interaction with,
Yeah.
should you then redo interaction as well? Yeah.
Okay, so the first thing to hope for is that you do not need to have any kind of interactions where the thing that you are interacting with has been transformed already, because interpretation is a nuisance. Because let's say in a standard interaction effect, you can think about, okay, the effect is like this for males and like that for females. But if the baseline effect already is nonlinear, but instead is, okay, if the effect is like this for males and it is like that for, this is not really nice. So the first thing to do is hope that you don't need it. And the second thing is, you have to be way more careful in interpreting what that interaction effect then means. Because if the thing that you take the interaction effect with is itself already nonlinear, then the comparison between these two effects becomes more complicated. That's the only thing that can be said about it. Anything else?